Example number 1, which is problem number 1 from the assignment, we're going to find the value of the derivative at each indicated extremum, and this is the particular function for number 1 that we're going to be doing. By the way, I just determined extremum means plural. Extrema, I believe, is singular, but I'm not sure on that. But anyway, just so you know, extremum is extrema, but plural. So this one actually only has an extrema because there's only one, but they're asking us to find what is that instant rate of change at this particular point of this function. So I hope I'm going to do this, but I hope that you're not going to be too surprised when we get the actual answer. So when I find f prime of x, I am going to have to derive this quotient. So we are going to be using the quotient rule. And I'm going to just do a quick differentiation process of this right now. Alright, so what you can see here is I had to do low to high minus high to low all over low squared, and what I got was this final result for what is the derivative of this function. So again, this is going to give me what is the rate of change, or what is the slope of the tangent at this particular, well, at any particular point, but I actually want to find this. So I am going to, at this point, plug in that x value of interest to me. And what you're going to see is I'm going to get 8 times 0 over and then 0 squared, so it's just going to be 0 plus 4 squared, and I don't really even care what I got on the bottom. This thing is equal to 0. Surprised? I hope not, because this was a critical point. This was a value at an extrema, or at an extremum, and what we found was that you should be getting a derivative of 0 at an extremum point. Example number 11, find the critical numbers of the function. So I'm going to be really lazy about this, and I'm going to rewrite my function because I'm going to avoid the product rule. I'm going to rewrite this by distributing that x squared. So now to derive this, I'm going to just have to use the sum and difference rule and then the power rules. So there I have it. And now I want to find the critical numbers of this function, so I am going to set this equal to 0 because, again, the critical values are those x values where the derivative, this is my derivative, notation for derivative, where my derivative is equal to 0. So I'm going to figure out what x values is my derivative equal to 0. So I am going to pull out a 3 here, a 3x actually, and I'm going to get x minus 2. And here then I'm going to set each one of my factors equal to 0. When x equals 0, this whole thing would equal 0, my whole derivative would equal 0. And when this x minus 2 is equal to 0, so in other words when x equals 2, my derivative is equal to 0. So these would be our critical numbers, x equals 0 and x equals 2. They're the x values in which our derivative right here was equal to 0. What I do want to show you is here's our function. I did take the liberty of graphing this for you, and what I hope you would see is at x equals 0 we have a peak, and at x equals 2 down here we have a valley. Not surprising. Alright, another example that I'm going to do is locate the absolute extrema. So again, the absolute extrema are those maximums and minimums. Unlike this one that was asking for the critical numbers, it was just asking what are the x values at which you're going to have some sort of interesting thing such as a peak or a valley occurring. So we just had to find the x values. Here, they're actually asking for the minimums and the maximums. This is a closed interval, so for sure there is going to be one minimum and one maximum to find. So we have those steps, these. We're going to be using these steps in order to find our extrema on this closed interval, which is guaranteed. Here I'm going to be starting out with let's find our critical numbers. So first I have to find the derivative of this function, so I'm going to be just taking it one by one just like we did in the last slide. Alright, so I just derived this function using the power rule and the sum and difference rule. Alright, again, I need those critical x values, so I'm going to set this equal to 0 and I'm going to solve. Again, this one is going to be pulling out a 3x. I'm going to get x minus 1. So what's going to happen then is I'm going to set each one of those factors equal to 0, and when I do that and solve for my x, I'm going to get x equals 0 and x equals 1. So these are my critical numbers. Had I just been looking for those, these would be it. But I need to find the absolute extrema, so the highest point and the lowest point. So step 2 says evaluate f at each one of those critical numbers in the interval. So I'm going to go ahead and do that. What is my function equal to at these x values? So down here I'm going to draw a table. Certain x values are of importance. They were my critical values. So 0 and 1. And then what are the y values at these critical points? And if you plug in f of 0, you're going to be getting, this is just going to all equal 0. So I'm going to get 0 for the y value. So at the critical x value 0, we're going to get the y value 0. At f of 1, which was another critical value that I found by using the derivative, I am going to be plugging that into my function. I get 1 minus, and then this is just 1.5 equals negative 0.5. So at 1, the y value is going to be negative 0.5. But then what we also have to consider are these endpoints, because at these endpoints we could also be having extreme absolute extrema. So I'm going to also plug in, well actually 0 is already in there so I don't have to plug in 0, but f of 4 would be a possible point of interest. So I am again going to find out, I want to find the highest or the lowest y, so I'm going to go back to my original function and I'm going to plug in 4. So 4 cubed minus 3 halves 4 to the second. So this all is going to be 64 minus 24, which would equal 40. So this is going to be at x equals 4, we're going to get 40. In all, what I can determine is this right here would be my minimum point on the graph, my absolute minimum. This right here is my absolute maximum. I'm going to go ahead and show you that graph now, and we're going to close this off because the interval we were interested in was from 0 to 4. I am going to locate these key points that I found. Here was an endpoint. Here was an endpoint. We tested this endpoint and we also tested this endpoint to see what is the value of those y's. And also we had at 1 a critical value. Right here is where our slope of our tangent would have been 0, and it also identified a possible peak or valley. And so what we did just find is here is our minimum and here is our maximum. Okay, the highest y value and the lowest x value all found by these 4 steps. What I do want to say is, if this had been an open interval, you're going to want to be careful because this would change things completely. If I wanted an absolute extrema in this open interval, what you'd have to understand is this would not be included and neither would this point. So there would actually be no, could you actually get the highest value? Would there actually be an absolute maximum? So think about that. So for these absolute extrema, you're going to want to look for that closed interval, because if it's open, it's a possibility that some absolute extrema may not exist. There is your homework. Good luck.